Hey guys, welcome back. My name is Ashutosh and you are watching Source Code. In this video, we are going to cover a few basics. We'll be talking about machine language, assembly language and high-level languages. Knowing about the basics is important, right? I'll start our conversation with Intel and AMD. How Intel and AMD is relevant here? Well, that's because they both manufacture processors. But there are other organizations as well which do manufacture processors, right? Well, Intel and AMD, they both follow a similar processor architecture which is mainly used in the current generation laptops and desktops, and that processor architecture is known as x86, which is a 32-bit version, and it has a 64-bit version as well, which is known as x86 64. So if you want to execute a behavior on the x86 processor, you need to write a program for it, right? So how can you do that? Well, when Intel folks invented the x86 processor, they used to write machine code for it. Now the machine code is just a sequence of zeros and ones. However, the arrangement of zeros and ones do have a meaningful information which we can also call as machine language instructions, which is easily understood by the central processing unit. So each instruction on the machine code can cause the CPU to perform certain tasks like load, store, jump, or any arithmetic logic unit operation. Now machine code is not easy for humans to understand. Writing a basic program in machine code might be okay, but writing a complex program can become a nightmare for humans, and we might easily lose the track of what's going on, right? Because after all, it's just a sequence of zeros and ones. So to solve this problem, assembly language was invented. In assembly language, rather than writing a sequence of zeros and ones, short abbreviations, names and numbers were used. At least it's much easy to understand in comparison to machine language, right? But what about the processor? The processor only understands the machine code, right? So before feeding the program to the processor, they used to convert the assembly language to the machine language. And how they did that? Well, with the help of assembler. So an assembler is a program which converts an assembly code to the machine code. Great, it made life much easy, right? Because after all, you just need to write your program in an easy to understand assembly language which can later be easily converted into the machine language. But unfortunately, assembly language has some serious limitations as well. Even though you are using human readable keywords, writing an entire program in assembly language is still not easy. For writing a program, you might have to use lots of assembly language instructions which can make your program very complicated. And that's the reason debugging in assembly language is not easy. Moreover, assembly language is not at all portable. That means if you want to write a program for any processor other than the x86 architecture like ARM, then you will have to write an entire new program. You cannot use the same program that you had written for the x86 architecture. Similar is the case with machine language. If you are directly writing your program in machine code, then for different processor architectures, you will have to write different entire programs. Well, researchers created a solution for this as well. They solved the problem of portability and readability by inventing high-level languages such as C, C++, Java, C# and many more. Now high-level languages are very easier to understand because the commands that we use in the high-level languages are quite close to the natural language that we use on the daily basis. And also, high-level languages require very few instructions to write a program in comparison to the low-level languages. But again, high-level language also needs to be converted into machine language before being executed on the processor. And they created tools like compiler and interpreter for that. Well, there are lots of differences between compiler and interpreter, which is a topic for some another video. For this video, it's enough to know that a compiler is a program which converts your entire high-level source code to the machine code which can be easily understood by the processor. So in the case of compiler, only after your entire source code is converted to the machine code, then only you can execute your program. However, in the case of interpreter, you can directly execute your program without completely compiling it to the machine code. Instead, an interpreter picks each statement from your high-level source code, converts it into the machine code and executes that first, and then it proceeds to other statements. Now, one of the biggest advantages of high-level languages is their portability. That means if you want to execute your source code written in any high-level language in different processor architectures, all you need is a compiler or an interpreter for that particular processor architecture. For example, if you want to execute your source code in a x86 processor architecture, you will need a compiler or an interpreter for x86. And in case if you want to execute your source code in ARM processor architecture, all you need is a compiler or an interpreter specifically for ARM. So guys, that's all for this video. I hope this video was helpful and you got a good idea of machine language, assembly language and high level languages. I'll catch you in the next video. Keep watching. Goodbye.